Alright, welcome back to the next lecture on arrays and vectors. So the last thing we talked about was undefined behavior. Don't try and access past the end of an array. That is bad. Okay? So let's have a bit more of a recap than that. So remember that arrays, they are a new type that holds smaller types. Alright? An array is something that holds a bunch of stuff of a certain type. So I can say int r bracket bracket equals 1, 2, 3. That's an array called R that only can hold integers. Okay? Looks like that, and it has 3 indices. Alright, arrays always have a specific size. Even if you don't mention it, you somehow mention it in the amount of things that you give it, right? One way or another, an array has a size, and you can't go beyond that. So this one, for example, has indices 0, 1, and 2, holding 1, 2, and 3 at those indices. Yeah, up front, you got to say what the size is. Can't change it later. Okay? So that is arrays in a nutshell. You can't pretend that there's an index here that doesn't exist. You can never add something to an array after you've made it. You can't be like, oh, I want this array to have 4 elements now instead of 3. Can't do that. Vectors, though, once we talk about those, it will be possible. So this is very similar to strings, right? Each string has an index for every character inside of it, and you can go at those indices, get and set the stuff, right? It's just slightly different notation. Instead of r at I, it's just r brackets I equals like r of I plus 1. That's how you can get and set something. You can always just print it out as well, right? R of j. So there's setting, there is, here's getting. Yeah. Let's spell C out slightly nicer. So that is arrays in a nutshell. Now that we remember them, let's do fancier things with them. Let's have a multi-dimensional array. So instead of storing just a line of stuff, let's have a grid of stuff. Okay? Let's do that. So a very common reason to want to have a grid of information, a multi-dimensional array with like an x indices and y indices, is maybe you want to store an image. Each image is made up of pixels, and it's a grid of those pixels, right? So you need 2 indices to access a particular pixel at that point. So like this one, maybe red is really the number 42 somehow, and I want to access that, okay? The way you get at it, saying that this is in an array, a multi-dimensional array, you would say r, maybe first the row, then the column, right? So I want to set r of row 2, column 1 to 42, okay? That's how you would talk to a multi-dimensional array. It's like first talk about the rows, then get the column. Okay? And the way you would declare one would look something like this. Okay? So if you have multiple indices, an array is called multi-dimensional. It's like you're accessing coordinates of it. And here's how I might declare an array that's 3 by 3. Okay? Maybe it's an array of ints. Int r, it has 3 first coordinates and 3 second coordinates. Okay? That's the idea. So that's how you declare a multi-dimensional array, and that tells you what you're allowed to access now too. It's just similar to a normal array, just you got multiple indices to work with. You got to get to both to get the underlying int that's stored there. Okay? So for example, if I declare this big long multi-dimensional array with 42 first indices and 84 second indices, the accessible indices, the ones that you can access, are all the way from r00, right? All the way to r01, dot, 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 all the way to what's the last valid index of r0? Well, it's up to 83, right? 0 to 83. So you can go along in that direction, and then you can also worry about the first index getting bigger. The final, bottommost, rightmost index of this multi-dimensional array has to be r41, right? 4183. Does that make sense? That's how it works, because this gives you 42 times 84 elements, starting with 0, 0, ending at 4183. Yes? And you can go even further than this if you wanted to. You can make a 3D array, int r 3 by 4 by 7. Why not? Totally possible, and that would be harder for me to draw, but I think you can imagine. Okay? So that's multi-dimensional arrays in a nutshell. It's all possible. You can use them. Let's see, do I want to give you a quick example of them? Let's check. Yeah, we got enough time, I think. Multi-dimensional.cpp. So I'll just do that first example. Int r of 3 by 3, so 3 by 3 array of ints. And I can set any valid index, so r of 2, 1, 42, and I can go and I can print that out. Okay? Notice that I can't, when I make a multi-dimensional array, I can't be like, what's r of 2? That's an invalid question to ask right now. Okay? The int is stored with 2 indices now. You gotta give the first index and the second one before you get your int back. That's how you kind of read it. Okay? So let's just show and prove that this prints 42. So we got our 42. Okay, that's multi-dimensional arrays in a nutshell. Good for grids of things like images. Alright, so I think you can see some good things about arrays. You don't have to make 50 variables if you want to store 50 things, but there are some bad things as well. Alright, so the biggest one is probably you have to say what the size of your array is the second you make it. You cannot change that size later either, okay? That's the first problem. Also, arrays, in general, they don't know what their size is. And so, first of all, they're not going to complain if you try to go past it. But if you give it to like a function, that function doesn't know where it ends, right? You have to pass along the size of your array a lot of the time. Like you got to store that and save that somewhere. Like, okay, my size is 42. I better not forget that. That's separate information. An array does not know how long it is, okay? And because of that, you can accidentally access past the end of it and not get a runtime error, not even know it. That's crazy. So like if you have an array of 4 valid indices, so this index is 0, 1, 2, 3, 4, it doesn't exist, but you can still access it a lot of the time. That's quite sad. So all of these problems, I hope you can agree that they are problems, we can solve with this cool thing that's very similar to an array called a vector. Okay? It is part of the C++ library. It is a library data type. All right. So before we get there, before we get to vectors, I want to show you one last important thing to do in an array. Okay. A lot of the time we want to swap the values at certain indices. So let me show you what we would like. So pretend we have this array, r of 3 indices. Let's say 0, 1, 2. So here is my array 1, 2, 3, and pretend that I would like to swap the 3 and the 1, right? Array of 0 with array of 2, swap them. Something like this. This becomes 3, this becomes 1. I cannot do the following, okay? I can't be like, okay, I would like array of 0 to become array of 2, and then I would like array of 2 to become array of 0. Think about, pause the video, understand why this is not going to work, okay? Did you try it in your mind? Because here's what happens. Here's the initial array. Let's run this first line. R of 0 becomes R of 2. Okay, that's going to set R of 0 to be whatever R of 2 was, which makes this become 3. Yeah? And then I'm going to run this line, and that's going to make R of 2 equal to R of 0. Oh, R of 2. I'm going to set this to be whatever R of 0 is. Oh, I'm going to keep the 3. 3, 2, 3. I just lost the 1. You see that? So this is not going to work. That is incorrect. The key idea, the trick, is you better save what you're about to overwrite first. So I'm about to overwrite R of 0 and lose it forever unless I save it somewhere before, okay, ahead of time. So here's the trick. Here's what you want to do. Here's 1, 2, 3. Before I go and I get rid of the 1, 0, 1, 2, I better save it. Maybe in a variable, usually we like to call it temp because it's a temporary variable. So save the 1 here, then do this line, erase, then do that line, and that will be 3, 2, 3, and then change this one up to set temp into R of 2. See how you still have the 1 lying around somewhere? That's going to fix it. Okay, so here's the proper code. First, save away the thing you're about to get rid of, and temp equals R of 0. Then you can do this as you would, replace R of 0 It's tucked away nicely now. And then set r of 2 to the thing that you saved. Okay, so try that out and make sure you understand why that's going to correctly swap the indices. That's an important thing to know how to do. Okay, you need a temporary variable here. And the pattern for this is, if you want to remember how to do this and never do it wrong, it's always the temp first, and then set it to one index, and then what appeared on the right before appears on the left on the next line. See how you have r of 0, r of 0? And then what appears on the right of this line appears on the left of this line. You see that? And they kind of like follow along like that, and then temp wraps around. I hope you see that. That's how I remember how to do it right. Okay? When in doubt, draw it out, though. Okay? That's swapping two things. Might as well give an example of that. So let's swap indices 0 and 2. So make a temp variable. I can start with 0 or 2, it doesn't matter, as long as that appears first on the next line. So bring r of 2 into r of 0, and then set r2 to whatever we put in temp, okay, which was the old r of 0. And now I can see out the entire array. And it will be 3, 2, 1 now. Yay. Okay, so that's swapping, and now we're ready for vectors. Okay, so it is a library. It's not a type that's built in to C++ like arrays are. You have to include the vector library, the vector header up here, and that gives us access to the vector type, which can also hold stuff. Okay, so vectors are very similar to strings in that you don't get to use these operations anymore. You use the .at instead. Okay. But you can put whatever type you want, not just characters, okay? So, a vector in C++ is also called a dynamic array. That's nice. Dynamic, it moves, it changes, okay? What that means is the size of a vector, it's very similar to an array though, the size can grow though. You're not stuck with what you initially give. You can grow the array with a push back function, okay? Technically it's called a method, but we'll get there later. You can use this pushback operation to add something to the end of a vector. Okay? That's really nice. So like, instead of R123, it's V123. And you can add stuff with pushback. You can push back a 4, for example, and that will bring in the 4. That's really super nice. Okay? Also, solves another problem of arrays. If you try to access an odd element, like one way over here, you will get a runtime error guaranteed. Okay, you use .at though to access certain indices of an array, or sorry, of a vector. 0, 1, 2, 3. You're going to get a runtime error if you try to do something silly, which is nice. You don't get that guaranteed with arrays. Also, vectors know their own size. So this vector right now, I've added something to it. It knows that it has 4 elements, okay? And just like arrays, you can set an initial size and an initial amount of elements, okay? So yeah, let me show this all to you. Let's talk about at just briefly. Instead of v of 2, like you would do with an array, which technically still works for vectors, you want to do v at 2. Just like for strings, okay? So that's the new syntax, which is the same as you used to know, but for a different type, okay? So first demo, let me show you 2 ways to make a vector hold 1, 2, 3 in that order, okay? And definitely take a look at this reference page. It shows you all the stuff you get with a vector. It has a size. Click on the size operation. It shows you like, okay, this is how you use it. It all looks like this. Size, resize, there's the at operator, there's the pushback operation maybe. You can erase stuff. There's a lot of stuff you can do with a vector, okay? So first let me show you 2 ways to make it hold 1, 2, 3. And the syntax gets a bit weird looking. It's very similar to that static cast that I showed you before, but you'll get used to it. So I want to use vectors. I'm going to include vector library. All right, here's how you make an empty vector. Here's how you declare a vector of ints. So it's not like this, int r like that, of 3 or something. Instead of this, you do vector angle bracket less than int greater than sign, okay? And then you call it v or something, okay? So this makes an empty vector that's capable of holding integers. It doesn't make sense to make an empty array, but it totally makes sense to make an empty vector, okay? Because I can add stuff to it with the pushback operation, okay? So I can grow the size of a vector with the pushback operation. I can say v.pushback 1, then 2, then 3. And now v holds 1, 2, 3 in that order, because pushback always adds to the end of a vector. Isn't that cool? And so now let me print out all of the vector, I guess. I can be like cout v at 0 space 1 and then 2. There, so that'll print out the vector, and you'll see 1, 2, 3. So that's the new cool vectors way of making a vector hold 1, 2, 3. You can also do the same as you would with an array to initialize a vector. So let's make a vector of ints called v2, and I can be, all right, just right off the bat make it hold 1, 2, 3. Okay? And I can print out that one as well. So this is v2. So similar syntax for that way. That still works, but we're using .at to get indices, okay? And then pushback grows a vector. Empty just holds 1 and 2. Now it holds 1, 2, and 3, okay? That's how they work, and that's a vector in a nutshell. So that's my first demo. Now the next demo, the useful one, the one that you'll probably use a lot of the time, is in combination with pushback, getting information from a user. Maybe we don't know how many things up front the user is going to type to us. We can get as many as the user gives us with a vector, because we can just push back as long as we need to. Okay, that's how it's going to work. So let's get infinite elements potentially from the user, as many as they want to type, and maybe we'll put them all into a vector. We'll get a bunch of numbers, let's say, and the user tells us that they're done typing and they want an answer back when they type -1. That's a special number that we won't put in the vector. That'll just stop the input. Okay? So maybe we'll get a bunch of numbers from the user, put them in a vector, and sum them. That might work. Okay? So, that could work. I think that's what I want to do. Alright, so let's make v3. It's a vector of ints, v3, and now let's repeatedly, while true, forever, enter a new number. Int n, cout. Enter the next number to put into v3, cnn, and then we'll push it back. Okay, to add it to the end of the vector v3, we push it back. v3.pushback n. Okay, so that just puts something else into v3. Okay, but we only want to do this when it's not -1. So if v3 is equal to -1, then break we don't want to include anymore. Okay. We stop getting input. Otherwise, add it to the vector. Okay, and continue. So that's my loop. Oh, sorry. If n, the number that the user just typed, is -1. So that will fill up v3, and then we could, I don't know, let's maybe, we could sum it. That would work. What, is there anything special that I want to show you first, though? Let me see. No, let's do it this way. Let's sum the array, or sum the vector v3. So we have to loop through the vector, okay? We have to loop through all the valid indices of the vector v3. How big is the vector v3? we know because we can do v3.size. That tells us how big it is. That's perfect for our purposes. Okay, so here's the trick. Here's what you do. For int I equals 0, you always start at 0. I is less than v3.size. That's the common way of doing this, I++. Because if v3 holds 4 things, the size is 4, the last valid index is 3, so we don't want to go ever to 4. We want to stay strictly smaller than it. All right, and then we'll do sum plus equals I, and we'll start sum at 0, and not I, sorry, v3 of I. There. So go into v3 at that index, add it into sum, and we're good to go. Okay. 1, 2, 3, 4, 5, and then -1. And so the sum of all the numbers from 1 to 5 is apparently 15. Okay? Maybe we should give the user like -1 to quit. That's usually what you say here. Okay? So that is my program. Hopefully that makes enough sense. 1, 2, 3, -1. So 3 plus 2 plus 1, yes, it is 6. That's how we go through all the elements of that vector and do stuff. Okay? So, yeah, that's a few good demos, I think. That's what I want to talk about. Just remember that pushback always adds to the n. Adds to the end. Adds a new element to the end of that vector. So that's that. Yeah, okay, let's talk about iterating through a vector some more. I just showed you this way. If you want to iterate through a vector, you can go between index 0 and stay strictly smaller than its size, I++. That works just fine. There's also a cooler way to do it, if you're interested. Let me show that to you. So, there's a new fancy way that works in C++ version 2011, so we're using 2017 version, so it's in there. It's called a range-based for loop, okay? It only works for vectors, it does not work for arrays, okay? So let me show you that. I think I want a new file. Vector iteration.cpp. So here's the standard way of going through a vector. Vector int v equals 1, 2, 3. If I want to use vectors, I better include the vector library. So there's my vector. Let's iterate through it and just print everything out. For int I equals 0, I is less than v.size. Size is 3, right? I++. Then cout v at I. New line. All right, let's do space. Space and then new line. So that's the way we know. Oops. There. So we got our 1, 2, 3. Fine. Let me show you the cool new way. Here's how you do it. You say, it's called a range-based for loop. For int elem, then you write a colon. You read the colon as in. For int elem in v. Do stuff. Maybe we can see out with the space. So you read that colon as the word in. And so for every element in v, call it elem, and let's use that elem in the body of the loop. Okay? It's a range-based for loop. And so what happens in this loop is, if v is 1, 2, 3, you have the elem variable available to you in the loop. And it ranges over all the possible values. The first time you hit the body of this loop, elem is set to the first element. It ranges through all the different ints in the int vector v. All right, so the first time elem is 1 for this body, so we print 1. And then, in the next iteration of this loop, because we're making elem get a chance at being everybody in v, we will reset elem to 2. Run the body again. Now elem's 2. Okay, this is just done automatically for you by C++. Then in the final iteration, elem is 3 because that's the third thing in the vector. Does that make sense? That's pretty cool. So it makes it easier to type and maybe easier to think about it. I'm not really using the indices for anything other than accessing things, so that doesn't really make sense for me to need that. So for int elem in v, elem gets a chance at being all the elements of v, and we could do the same thing. Cout elem space new line. Okay? And so this will do the exact same thing as the above. Okay? Elem gets a chance at being every element. In order, goes from left to right. Okay? So that's called the range-based for loop. For all intents and purposes, it is equivalent to this one right here. Okay? Just goes through it from left to right. So that's 2 different ways to iterate through a vector. Now you know. Let's talk about sorting vectors, because that might be something that you want to do. There is a library that includes a sort function for you already, which is super nice. So let's go there. It's the algorithm library. So it's an other algorithm. There is a sort function. There's a bunch of cool stuff here. Definitely take a look at that. Where is my sort? There it is. Sort. And so it gives you some examples of how it works. It takes some weird types. Don't worry about that. I'll tell you how to do it properly. But it will sort either a vector or an array for you. It knows how to do that. It's really cool. So, yeah. We're going to use this sort function to sort a vector and an array. Either one. So what you do, the sort function, you give some way of obtaining, that's just how it works. The first thing that you give is the starting point of the data structure that you're working with, maybe the start of the vector, the start of the array in a special way, and then you give, it's called a pointer, you give one past the end. You give a way of accessing one past the end, we say. Try to go one more into that thing, into that vector or that array. I promise this will make sense when I give an example, but that's what sort needs. It needs a way of accessing the start of the thing you're trying to iterate through and sort, and then also a way of accessing, or where it might be, the location that is one past the end of that array slash vector. It will never access it. It just needs to know where that vector slash array ends, and that's what it's going to take. Okay? It's very weird to think about. But yeah, you give the beginning and ending location of your vector array in memory. And the in memory is very special, and I'll tell you how to do that. Okay? So it's really one past the end, but that's okay. This is already too much information. But this is how it works, and here's how to use it. That's all you need to know. Okay, so you say sort. If you have a vector, you say v.begin and v.end. Those are special things that give you the memory location of the start and one past the end of the vector. Okay, so if we go back to the vector library, you'll see that those exist. There it is, begin and end. It's called an iterator. Iterator to the beginning, iterator to the end. It just tells sort where it starts, where it ends. Okay, so that's how you sort a vector. Just remember that. Sort v begin and v end. And then an array, it also looks weird. You say sort name of the array without any brackets, and then r plus, you're doing math on the array, r plus the size of the array is the memory location one past the end. You don't have to worry about it. Feel free to ask me about it in office hours, but you can just memorize how to do it. Okay, that's how you sort a vector. That's how you sort an array. And let me show you that. So I'm going to do both. So let's do vector and an array. So here's my array, 8, 6, 7, 5, 3, 0, 9. And here's my vector. There we go. they hold the same stuff. Let's sort them both. So to sort the array, you say sort, name of the array, and then r plus the size of the array. So apparently this is 1, 2, 3, 4, 5, 6, 7. R plus 7. Okay? That's how you do it. And to use sort, I need the algorithm library. All right, so that's how you sort the array. And then the vector is sort v.begin, parenthesis, parenthesis, v.end, parenthesis, parenthesis. Okay? That's how it works. And then I can output both. So for int I equals 0, I is less than 7, I plus plus, that's all the array stuff. I can do that, cout array of I, space, new line, and then let's do the cool vector iterator, range-based for loop for v, because we can, right? So make an array, make a vector, sort them both, print out the array, print out the vector, should be in sorted order. Oh, sorry, sorting. Yay! So those look like two sorted vectors slash arrays to me. So that's how you do it. That's the trick, and that's the syntax. I can definitely explain more in office hours if it feels too mysterious, but in a future lecture, it'll make slightly more sense, I promise. Okay, now I have a question for you. Let's pretend, all right? Pretend that we have a vector called v of some size. Don't know what it is. You can always get it with dot size, right? Like here's v. It is 1, 2, 3, 4, let's say. And I want you to think about, we're not in class, so you don't have a group to work with, but I want you to think about how you might reverse this vector. Like take v and in place, still v, right? Replace all the elements with 4, 3, 2, 1. How will you do it? Okay? And this code, whatever you're thinking about, it better work regardless of the size of the vector. Like you can't hard code, okay, bring this index into here, bring in this index into here, and all that. Okay? It has to work regardless of the size of that vector. So think about that, and then we'll come back and talk about it together. But it's very good practice to brainstorm what might happen here. Okay? So, assuming you just thought long and hard about this, let me try and give you some intuition of the standard way of doing this. Okay? So, also, like, the size shouldn't matter. So if v2 had a different vector, it was 1, 2, 3, 4, 5, had 5 things, we need a way just as well to change v2 into 5, 4, 3, 2, 1. Yeah? That's what we want. And let's talk about what needs to happen, okay? You might have noticed that there's some symmetry involved. The keyword is swapping, right? Maybe I'll use a different color just to highlight this last fact. If I have 1, 2, 3, 4, and I want to turn it into 4, 2, 3, 1, look at what needs to happen. These need to go away, or these need to be replaced with each other, and these need to be replaced with each other. Does that make sense? That's what needs to happen. And so there's kind of the midway point is very important, right? Because that's when you don't want to wrap back around. Okay? You want to swap on opposite sides of that midway point. Okay? So maybe that's what you came up with. Let's go into that in more detail. Okay? And then we'll implement it next lecture. So here's what we want. All right? Here's what we'll notice. So let's try everything out in a lot of detail now. So here's my vector. Call it v. 1, 2, 3, 4. What I need to do in order to correctly swap this, or to correctly reverse this vector, right, is 2, 0, 1, 2, 3, is to do this. I want to swap 4 and 1, and I want to swap 2 and 3. Yeah? So it's two swappings. Swapping of these two and a swapping of these two. Does that make sense? That's what needs to happen. So, how many swaps, depending on the size of the vector? Because here's v2, right? v2 let's pretend it had 5 elements. It shouldn't matter. Our algorithm better work for all of them. 1, 2, 3, 4, 5. And this one's weird because here's the midway point right in the middle of 3. That's interesting to think about. To make this 5, 4, 3, 2, 1, you still need to swap this one, these two, and these two. And actually 3 can be left alone. You see that? So swap around those. So here's the size of the vector 0, 1, 2, 3, 4. The size of this is 5, the size of this is 4. How many swaps need to happen depending on the size of the vector? Because that's the first important thing to think about, okay? We notice first that swapping needs to happen, right? Swapping, let's write that down. Swapping needs to happen. Right? And then, well, if we walk it through, like, okay, I need to swap index 0 with what? Regardless of the size, because sometimes it's 3, sometimes it's 4. How can I get that? Always correct. Swap index 0 and what? Without hard coding a number. It's always based on the size, right? v.size. That would give me 4 here, but I want 3 to get the last index. v.size minus 1. Yeah, that's the first thing that I swap. This one and this one. It's the same for here. v2.size minus 1 is 4. That's the last valid index. That's perfect. I want to swap those first. And then I want to swap index 1 with, how do I get the 2 and make it always correct? 1 and v.size minus 2 now. Does that make sense? And depending on how long the vector is, / array is, you got to do that a bunch of times. Increment that, decrement that. Okay? That's how it works. How do you know when to swap? Or how do you know when to stop swapping is the next question. Should I then continue to go and swap 2 and 1 after I've swapped 1 and 2? No, that would put it in the right spot again, right? So I only want a certain number of swaps. That's going to be very important. So let's take a look at that. Because let me draw out v1, or just v again. 1, 2, 3, 4. Notice that I want to stop after just 2 swaps, right? I want to swap 0 and v.size minus 1, 4 and 1, and I want to swap 1 and 2 to make 3 and 2 at the values in there, and that gives me 4, 2, 3, 1, or 4, 3, 2, 1. Excuse me. We only needed 2 swaps. For this one, we also needed only 2 swaps. How can we come up with that number? Because that's how many times like a loop is going to go, right? We need to control how many times our swapping loop continues. So it looks like it's based on the size, and it's kind of like half the size, right? How many swaps here? It's v.size is 4 over 2, that's 2, right? Size over 2 swaps here. And then, what about this one? The size is 5, but I also need 2 swaps. Does that still work? Size over 2 swaps here as well. It does, because it's integer division. 5 over 2 is still 2, right? It's 2.5, and the 0.5 gets chopped off. So, you always want to do v.size over 2 swaps. Yes? Depending on the size of the vector. Isn't that nice? And you don't want to continue anymore, because look what would happen if I continued this and accidentally like swapped index 2 and v.size minus 3, and swapped index 3 and v.size minus 4. That wouldn't work because it would undo what I just did here with those first 2 swaps. It would swap, okay, 2 and 4 minus 3 is 1, so it would end up swapping these, which would make it 2 and 3 again, and it would end up swapping these, which is 3 and v.size minus 4, so 4 minus 4 is 0. it would swap these and make it 1 and 4 again. It would give me back the original array. It would undo what I just did. So I don't want to go that far, which is maybe what you first think to do. Like I want to have 4 swappings if I have a size 4 array. No, it's only half of that. Size over 2 swaps. Okay, that's a lot of content. Does that make sense? Please yell at me if it does not. That is the algorithm that we're going to implement. So it looks like we're going to start swapping with index 0 and v.size -1, do our swapping algorithm for those, and then increment this first index and decrement this second index, and do just as many swappings as there is in the number size over 2. Okay? And that will correctly swap the array regardless of if it has even elements or odd elements. An even number of elements or an odd number of elements, it will still work just fine. Okay? Because once you have an odd number of elements, you have something left in the middle that doesn't need to be swapped. Like maybe you could swap it with itself if you wanted to, but that's not necessary. Okay? So that is reversing an array, and that's just our brainstorming stuff. We are going to implement it, but we're going to have to wait until next week for that. So I will see you then.